Hey everyone, I'm Joshua Deemer and welcome back to Lesson 3 of our Java Programming Tutorial series. Let's jump right into the lesson. Our first topic for today is standard, or also known as arithmetic operations. This includes the plus, minus, multiplication, and division symbols. All of these are used in programming just to do basic arithmetic. So I've got 4 variables here, 4 integers, right? So they're 4 bytes each, and they're named addition, subtraction, multiplication, and division. I don't have them set to anything just yet, that's why there's so many errors, but let's go over these 4 operators. Okay, so let's say we have 4 plus 2. This resolves this error because we just set it to 4 plus 2, which is 6. Subtraction, let's do 4 minus 2. That's going to equal 2. Let's go ahead and do 4 times 2 for multiplication. That's going to equal 8. And let's do 4 divided by 2. That's going to equal 2 as well. So it's really that simple to use arithmetic operators. However, we can make it a little more complicated, but first let me show you something. This here, if I made this 5 divided by 2, this answer in reality is 2.5. But since this is an integer, it's not 2.5 anymore because an integer is a whole number. So what it does is it takes this decimal point and cuts it off. So if we were to have a division that is, let's say it is 7 divided by 4. This is 1.75. This still cuts off the whole thing to make it into 1. It is not going to round up, okay? It always cuts off that decimal point. Okay, so let's move this back to 4 divided by 2. Now you can do the same thing when you reinitialize 2. So you can say addition equals 2 plus 2, which makes it become 4. You can say subtraction equals 2 minus 2, which is 0. You can say multiplication is equal to 2 times 2, which is 4 as well. And you can say division is equal to 2 divided by 2, which is 1. Now, if you really, let me go over this as well, if you really did want to store 2.5 into division here, you would need to change division to a double. So now 2.5 is going to be stored properly into division. However, remember that if you put an integer here, then it is going to chop off that decimal point. Okay? Now, let's go ahead and go over really quick how to use these variables to make things a little more interesting. So let's say we want to add subtraction and multiplication together and store it in addition. So let's take addition, set it equal to subtraction plus multiplication. You'll notice that the warnings actually went away for subtraction and multiplication because we're now using them. It's not just being set to something, they are actually being used. And so the answer to this question is going to be subtraction, which is 2, plus multiplication, which is 8, making addition now equal 10. You can also do something like this. Addition, if I spell it right, addition equals addition plus 5. What's this going to equal? Well, we're setting addition equal to itself, which is 10 at the moment. It's not 6, it is 10 because we reset it here. Then we add 5. Okay, so this now equals 15. if we have the same line of code underneath it, it's not going to equal 15 anymore, because now we're taking 15 and adding 5 to it. So now it equals 20. Okay? So we can use plenty of different techniques in order to spice up our arithmetic a little bit. The next arithmetic operator we're going to be looking at is the mod operator, which is a percent sign. What this does is it takes the remainder of a long division problem. So if we have 7 divided by 4, 4 goes into 7 one time. So you do 1 times 4, you get 4. So 7 minus 4 is equal to 3. And that 3, you could continue to get the decimal point for 0.75, 1.75 as the complete number. However, we want to take the remainder. So the remainder for this problem is 3. So 7 mod 4 is 3. Let's go over some examples of mod really quick, okay? I know it's a little confusing to see in code, but this is how it looks, okay? So what we do here is we say it was 4 divided by 1, that is 4. And so since it's a clean number, it's literally 4.00, right? There is no remainder. Okay, so that means the result will be 0. And we got 4 divided by 2, that is 2. It's literally 2.00, which means there is no remainder as well. Now we got 4 mod 3. Now we're starting to get interesting. That is going to... 3 goes into 4 one time, right? But there's a little bit extra left over, right? It's 1.33, I believe. If we do 4 divided by 3, yep, 1.33. So there is a remainder here. And there's 1 extra from 3, so that means it's 1. If you do 4 mod of 4, that's 4 divided by 4, which is 1 in division, and there's no decimal point afterward, so that means there's no remainder. Now 4 divided by 5 is 0.8. Okay, there is a decimal point after, so we need to figure it out. How far away is it from the multiple of 5? It is 4 away, because a multiple of 5 can include 0, 5, 10, 15, 20, right? And so it is 4 away from 0. So that means the remainder is 4. If we kept on going with this, and result 6 is equal to, let's say it is 100% of 4. I can know right off the top of my head. Let's not do 100. Let's go ahead and do 90. So with 90, I know off the top of my head that this is going to be 2. The reason I know that is because you look at multiples of 4. You go 0, 4, 8, 12, 16, 20, all the way up to 90, because it goes 80, 84, 88, 92. All right, so we got what we need. Here's the nearest divisible 4, and it is 2 up from it. So that means it's 2. Okay, hopefully this helps with understanding mod. Some uses of mod that you can have are, for example, finding an even number. Because let's say, for example, you have everything divisible by 2 here, right? And you have 0 here, 1 here, 2 here, 3 here, 4 here. Let's say you have that. So by divisible by 2, by multiples of 2, this is 0 spaces away from a multiple of 2, which means it's 0. If you do 0 divided by 2 equals 0.00, which there's no decimal point, right? If you do 1 divided by 2, 1 is 1 away from the nearest multiple of 2, or for the lowest multiple of 2, so it's 1. 2 is 0 away from the multiple of 2. 3 is 1 away from a multiple of 2. 4 is 0 away from a multiple of 2. Can you see the pattern here? If I made more, 6 and 7, you got 5 mod 2 and 6 mod 2. It would follow this pattern of 0, 1, 0, 1, 0, 1, and you can tell which one is odd or even because of this. You can say that 1 is odd and 0 is even, because it's always going to be that far away from a multiple of 2. There are 6 more arithmetic operators I want to discuss with you guys. Plus equals, minus equals, times equals, divide by equals, plus plus, and minus minus. These operators make life much easier. So as you can see here, we have our 6 arithmetic operations: plus equals, minus equals, times equals, divide by equals, plus plus, and minus minus. I also initialize a variable, an integer, number, and set it to 4. Let's see what these do really quick. So if I say number equals 5, we've reinitialized it, right? But what if I wanted to, let's make this 2. Make it a little easier for our brains. So let's say I wanted to add 2 to the already existing number. Now, I've showed you guys how to do that already by saying number equals number plus 2. So we're taking the 4 that it already is, and we add 2 to it, making this equal 6. Right? You can also do minus 2 times 2, divide by 2, and it'll do the same, similar operations. It'll take itself and do the operation after. Okay, cool. But there's ways that we have to make this easier for ourselves, and that's why we have these operators. If we say number plus equals 2, this will also give us 6, because it's taking number and it's adding 2 to itself. It does the same exact thing that this does. Okay? But it's much shorter. Let's go ahead and try minus equals, we'll say 4. What this does is it takes this newly created 6 and it subtracts 4 from it. So now it's 6 minus 4, which equals 2. You can do number times equals 4. So now we take 2, which is its new number, right? Because that's what we reinitialized it to. This is a form of reinitialization. It's just making it less wordy, okay? This is equivalent to saying number minus 4. And this is equivalent to saying number times 2. They're just simpler. So let's change these back. So what is 2 times 4? That is 8. If we say number divided by equals 2, now we're taking 8 and dividing it by 2, and we're setting it to number. So that is 4. We're back where we started, but now you know a little bit more about these arithmetic operators. You might be wondering what these two do now. So let's take a look. You got number plus plus. That's literally all it is. Number plus plus. What this does is it takes number and adds 1 to itself. Okay? So this is equivalent to saying plus equals 1. Or, which is also equal to saying equals number plus 1. So it's taking something this complicated, breaks it down to this, to this. So now 4 becomes 5. And if you do it again, it's now 6. If you do it again, it's now 7. You can do this backwards, too, if you want. This will equal 8, but this will disturb the order of operations. It'll still say 8, but let's say you're printing it out and you want to also increment it by 1 at the same time. I'll show you guys the code for printing out. If you say number plus plus, this will take the current number, which is 8, and print it out. Then after that, it's going to add 1 to 8, which is 9. But if I say plus plus number, it's going to do the reverse. It's going to say 8 plus 1 equals 9. Now print that. Okay? So these are all of the basic arithmetic operators. Okay, let's practice this a little bit. This is pretty important to remember, so I would suggest doing this on your own, but if you want to just follow along with us, that is perfectly fine as well. So firstly, it says create 5 variables which use the first 5 standard arithmetic operators however you want. Okay, so 5 variables which use these 5, it should use them all differently. Take those 5 variables and make them each use 2 of the bottom operators. So those 5 variables can use plus equals and times equals. And then the next variable you can use minus equals and divide equals. The next variable you can use times equals and plus plus. The next one you can do minus minus and plus plus. But I want you guys to be able to use all the operators. Now, one thing I forgot to go over before was minus minus, so let's do that really quick. So int result equals 5, result minus minus, wow, okay. Result minus minus will give us now 4. If we do it again, it'll give us now 3. It does the same thing as plus plus, except the opposite, okay? And the same applies to minus minus result. This will give you, well, since we're here, it would give you 3 and 2, but if you were to print it out to the console, like this, it would print out the 2, and then it would subtract 1 and store it as 1. But if you did minus minus result, it would do 2 minus 1 and then print. Okay? So now go ahead and pause the video and try to do this on your own. Otherwise, let's do it together. So let's do int first is equal to 5 plus 1. Sure. Int second equals 2 minus 2. Int third equals 3 times 3. Int fourth equals 8 divided by 2. Int fifth is equal to 5 mod 3. Okay, cool. So let's guess the answers. This will be 6, this will be 0, this will be 9, this will be 4, and this will be 2. Okay, awesome. Now let's go ahead and do the second part. So first, plus equals 2. First, minus equals 2. Second, times equals 2. Second, divide by equal 3. Third, minus equals 4. Third, minus minus. No, don't do that again. Fourth, plus equals 4. Fourth, plus plus. Fifth, divide by equal 2. Fifth, times equal 100. Now let's go ahead and guess these as well. So first, it's starting at 6. So this adds 2 to it, making it 8, subtracts 2 from it, making it 6. Second is 0, so this turns into 0, and this is 0 as well. Third is 9, so this becomes 5, this becomes 4. Fourth is 4, so now it is 8, and then it becomes 9. Fifth is 2, so this becomes 1, multiplied by 100 is 100. Keep in mind, when we do any form of operation with these operators, we need to follow P.E.M.D.A.S rules. Now, if you don't know P.E.M.D.A.S or need a refresher, that is parentheses first, exponents second, multiplication and division third, they just go left to right, addition second to last, and then subtraction is last. Let's go ahead and see an example of this in code. Alright, I have some examples here. If you want to fill them out yourself, you can, but you can follow along here as well. So let's follow these P.E.M.D.A.S rules to answer these questions. You have 5 times 2 plus 3. This one's real simple. You do 5 times 2, which is 10, plus 3. And the answer is 13. The next one is not as simple because of P.E.M.D.A.S. M is first, which is multiplication. That means you do 2 times 3 first, which is 6. Then you add 5. Okay, so 6 plus 5 is 11. Notice that these two are different results. Just by flipping around a couple symbols. It's not that easy at first, but once you get used to it, you got used to it. Okay? 2 plus 2 times 3 plus 3. The answer to this one is multiplication first. So you make sure to do 2 times 3 first. That's 6. Then you add 2. So 2 plus 6 is 8. And plus 3 is 11. This one is different. We use parentheses. So P.E.M.D.A.S, P is at the front, parentheses is at the front, so we do those first. 2 plus 2 is 4. 3 plus 3 is 9. So 4 times 9 is 36. Here we have something different. Now, I added this one because a lot of people think because it's P.E.M.D.A.S, multiplication comes first and then division. However, multiplication and division are of the same importance, so they just go left to right with this. It's not 2 times 5 and then 4 divided by that. It is instead 4 divided by 2, then 2 times 5. So 4 divided by 2 is 2, then 2 times 5 is 10. Finally, we got a little more complicated here. So we got 2 minus 2, which is 0. Then 2 times 5, 0 times 5 is 0, so this equals 0. 2 divided by 2 is 1. Okay, 1 times 5 is 5. And you got 0 plus 5. The answer, final, is 5. These next operators are a little bit tricky. These are binary or bitwise operators. The first 3 we'll be looking at are AND, or exclusive OR. Now, I know binary can be confusing, but let's break it down a little bit inside of code. So here's that 0b that you've seen before in the first episode, where we're defining this as a binary number. So we have 1010 as a first number, and 0110 as a second number. This one means 10, and this one means 6. Okay? So I've used all 3 of the bitwise operators here, AND, OR, and exclusive OR. So what this is going to do is it's going to take this first number and compare it to the second number and give us the result based on the AND. I lined this up for us so that we can compare it equally. I didn't do a full byte, I just did what is the vocab word for a nibble. Technically, what this is doing is it's doing this, but I'm just excluding the prefix to zeros. So with AND, let's take a look at this one. Okay, this is a 1. Alright, but this is a 0. So that means that this is going to be a 0 in the first slot. Okay, let's take a look at the second slot. It's a 0 here. Okay, so we know that it's going to be a 0. Both of these have to be a 1 in order for it to be a 1. That's why it's an AND. This one's a 1, but it doesn't matter because this is a 0. This one's a 1 and this one's a 1, so that means it's going to be a 1 in this slot. This one's a 0 and this one's a 0, so this definitely means that there's nothing in this slot. So the answer for this one is 2. Or means that you have to have a 1 in either or. Okay, so this one has a 1 here, so that's true. And this one's a 0, so that doesn't matter. There was 1, 1, so that means there's a 1. This one's 0, okay, so it's starting off as 0. This one's a 1. Oh, there is a 1, so another 1. This one has a 1 and a 1, so this one's definitely a 1. This one has a 0 and a 0, so that means it's 0. The answer to first bitwise OR second is 2 plus 4 plus 8. So that's 6 plus 8, that is 14. So exclusive OR takes, basically, it nullifies and loves OR. So let's go over what that means really quick. So this or this, okay, yeah, that is a 1, so there is a 1. This or this, yeah, this one's a 1, so it's a 1. Okay, so starting off like the OR. However, since these are both 1, it's 0 for exclusive OR, hence why it's exclusive. 0, 0. Okay, that's also off, so it's a 0. The answer to this one is, this is 4, 8, so the answer is 12. Now the final two that I'm going to introduce for binary or bitwise operators are bit shift right and bit shift left. Let's take a look at this code. So we've got bit shift left and bit shift right, and I have them set both to 1101 or 0000 1101, which is 13. Okay, both of them are 13. So let's take a look at this one. We shift the bits to the left by 1. Now we can shorthand this by saying this. This will do the same exact thing. In fact, let's just do that. To the left. And to the right. So what this is going to do is it's going to take this 1101 and shift it to the left 1. So it's going to be 11010. So now it's going to be what's that? 16 plus 8 plus 2, which is equal to 24, 26. Okay? Then this bit shift by 2 will take it and it'll be 11010 and then adding 2 zeros because it's shifting it to the left twice. Okay? And so that is, let's see, that will be 8, 16, 32, 64. So 64 plus 32 plus 8. So that equals 96 plus 8, which equals 104. Right, so suddenly this 13 becomes 104. Okay, so bit shifting does quite a lot, but you'll notice that it actually takes the number and doubles it. Right? If I were to bit shift this once instead of twice, removes a 0. So now this is 32, 16, and 4. 32 and 16 is 48 plus 4. Which is 52. Oh, it doubled again. And if you saw, 104 is double of 52. So that's just one way that bit shifting can be used. This way is actually the opposite. It's dividing by multiples of 2. So if we have bit shift to the right 2, we've got 1101, which then becomes 1, 1, basically, right? It becomes 3. And then if we bit shift once again, it becomes 1 because this 1 gets cut off and it becomes 1, which is 1. And now we have our number. But if we take a look here and do this, that means that it becomes, instead of 1101, it becomes 110 because this 1 gets cut off, which is 2, 4, that is 6. And if you take 13 divided by 2, you do get 6. If you make it into an integer, of course. And if you do it here, that's 110 to 11, which is 3. That's 6 divided by 2. If you do if you do it one more time, you got 1 goes to 1 divided by 2. It's an integer, so it would technically be 1.5, but it turns into 1 through the bit shifting. Now, this next part might be a little too complicated. However, I do want to go over it since it is a usage people have for bitwise operators with the AND bitwise operator. So let's say you have permissions here, right? And we've talked about this before, actually, where we need to check if someone has, say, I did this before also. I did it on the top instead of the bottom. We want to check if someone has this specific permission, which might be whether or not they have view permissions. And this one is they have edit permissions. This is they have delete permissions. This is they have admin permissions, sort of thing, right? We want to check if they have this permission, which means it'll be a 1 if they do and a 0 if they don't. So now we have our permission check. We're checking to see if they have that specific permission. So now this is where it gets a little more complicated. We check if this and this is equal to this. Okay, so we check if this and this, okay, so this is 0, this is 0, this is 0, this is 0, because these are all zeros. Then this one's 0, this one's 0, and this one's 0, because these three are all zeros as well, since we're doing an AND bitwise check. Here is a 1 and a 1. So that means that the result is going to become 0, 0, 0, 0, always, and then 0, 0, 0, always, because that's what we have for these 7. But this one will change depending on if this is true or false. Right? So since it's a 1, and it matches this 1, this is a 1 as well. So now, this result equals this permission check, and so this has permission will be true. If you set this to 0, however, this will become 0 as well, which means it does not equal the permission check, and so this will be false. Again, this is complicated. It's a lot more complicated than what we've been talking about, so you don't need to have it all soak in and everything like that. But if you can get the general concept as to why some people might use this, then that is very beneficial for you. That's the end of this episode. Next episode, we will be covering strings and printing in Java. Thanks for watching. Feel free to comment what your thoughts are on this series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!